What if I told you there's a creature that can hunt you without seeing, hearing, or even smelling you? It doesn't need light. It doesn't need motion. All it needs is the tiny electric signal your heart gives off. Just one beat, and you're already found. Sharks possess a sixth sense so precise they can detect the electrical current of a fish buried under inches of sand. Not magic, not science fiction, just pure biological power. And here's the wild part. This sense works even in total darkness, in complete silence, and from unbelievable distances. So how do they do it? What's the secret behind the supernatural detection system? Stick around, because once you understand how sharks sense electricity, you'll never look at the ocean or your own body the same way again. Electroreception is the ability to detect electric fields in the environment. It's a biological sense, just like sight or hearing. But instead of picking up light or sound, it picks up electricity. This electricity isn't from power lines or batteries. It's the natural electric signals given off by living things. Every time a heart beats, every time muscles move, tiny electrical currents are created. Even when a fish stays perfectly still, its body still produces an electric field just from being alive. Water, especially salt water, conducts electricity well. That's why sharks are able to detect these tiny signals from other animals, even when those animals are buried under sand or hiding in the dark. In fact, electroreception works so well that a shark can sense the faint electric pulse of a fish from several feet away, even if it's not moving at all. This sense gives sharks a huge advantage in the ocean. It helps them find food, avoid danger, and understand their surroundings in a way no human ever could. While electroreception might sound like science fiction, it's a very real and very powerful sense that sharks have used for over 400 million years. The key to a shark's incredible ability to sense electricity lies in something called the Ampullae of Lorenzini. These are tiny, jelly-filled pores found mostly around the shark's nose, snout, and head. At first glance, they might look like small dark spots or freckles, but inside, they're some of the most sensitive biological tools in the animal kingdom. Each ampulla is connected to a canal filled with a special gel that conducts electricity. At the end of the canal is a cluster of sensory cells connected to the shark's nervous system. When electric signals from the water pass through the gel, they trigger these cells, sending instant messages to the brain. These pores are so sensitive that sharks can detect electric fields as weak as 1/1,000,000th of a volt. That's 1,000,000 times smaller than the electricity from a standard AA battery. In fact, no man-made machine comes close to this level of precision in underwater sensing. The name Ampullae of Lorenzini comes from the 17th century Italian scientist Stefano Lorenzini, who first discovered them in rays and sharks. Today, we know they form a complete electrical scanning system that helps sharks see the invisible world of electricity all around them. For a shark, survival in the ocean depends on more than speed or strength. It's about sensing what others can't. Electroreception gives sharks a major edge, especially when hunting. Many of their favorite prey, like stingrays or flatfish, bury themselves under sand to stay hidden. But even when a fish is completely motionless and invisible to the eye, it still gives off a weak electric field from its heartbeat and muscle activity. That's exactly what the shark is looking for. Sharks often rely on electroreception in the final moments of a hunt. When they get close to a target, they use their Ampullae of Lorenzini to zero in with pinpoint accuracy. This is especially important when visibility is poor, such as at night in murky water or deep beneath the surface where light doesn't reach. Even the quietest, stillest prey can't hide from electricity. Young sharks are born with this sense fully functional, which helps them locate small prey early on. It's not just for hunting larger animals. Even tiny shrimp and crustaceans give off electric signals that a shark can track. Without electroreception, many of the stealthy ambush tactics sharks use simply wouldn't work. This sixth sense turns the ocean into a map of invisible signals, one that sharks have been reading effortlessly for millions of years. Electroreception isn't just about hunting. It also plays a big role in how sharks move through the world and find each other. One of the most fascinating uses of this sense is navigation. Scientists believe sharks may use electroreception to detect the Earth's natural magnetic field. Now, this works because ocean currents and the planet's magnetic field can generate faint electrical patterns in seawater. By sensing these patterns, sharks may be able to read the ocean like a built-in GPS, helping them travel thousands of miles without getting lost. This is especially useful for species like great white sharks or hammerheads, which migrate over long distances to feed or breed. Even across entire oceans, they seem to find their way with incredible accuracy, and electroreception could be one of the tools they're using. There's also evidence that this sense might help during mating. Some researchers suggest sharks could use electroreception to detect electrical signals from other sharks, especially when it comes to recognizing potential mates. Since each shark has a slightly different electrical signature based on size, shape, and movement, this could help them identify individuals or even distinguish between males and females. In short, electroreception is more than a hunting tool. It's a full-body communication and orientation system built perfectly for life in the sea. Sharks don't just have electroreception, they have one of the most powerful and sensitive sensory systems in the entire animal kingdom. Their ability to detect electrical signals is so precise that they can pick up voltage changes as small as 1/1,000,000th of a volt. To put that into perspective, it's like detecting the electrical current of a flashlight battery from thousands of miles away. If the signal could travel that far in water, this sensitivity means a shark can easily sense the heartbeat of a fish hiding beneath a thick layer of sand, or the tiny muscle twitches of an injured animal from several feet away. Even a crab, staying completely still, it still gives off a signal, and the shark can lock onto it instantly. Researchers have tested this in controlled lab environments and in the wild. In one experiment, sharks were able to detect small metal wires that emitted low-level electrical currents, proving they could sense even artificial signals. In nature, they don't need movement, noise, or smell. The electricity alone is enough. Compared to humans, sharks are in another league. We can't naturally sense electricity at all, not even strong currents, without tools or machines. For a shark, this level of awareness is built in, always active, and always working. At first glance, the hammerhead shark's wide, flat head looks strange, almost cartoonish. But there's a powerful reason behind that unusual shape. It gives hammerheads a huge advantage when it comes to electroreception. That wide head, called a cephalofoil, is packed with hundreds of ampullae of Lorenzini. Because the head stretches out to the left and right like wings, it gives the shark a much wider range to detect electrical fields. It's like turning a small flashlight into a giant floodlight. Suddenly, you can see more of what's around you. This design allows hammerheads to scan the ocean floor with incredible precision, almost like sweeping a metal detector across the sand. That's why they're especially skilled at hunting stingrays, which often bury themselves deep under the seabed. With their electrosensitive heads spread out wide, hammerheads can track hidden prey better than nearly any other shark. Studies show that the spacing and layout of their ampullae help them triangulate signals more accurately, meaning they not only detect electricity, they can figure out exactly where it's coming from, faster and more efficiently. So while their odd look might seem funny to us, in the shark world, hammerheads are walking examples of evolutionary genius. Humans don't have electroreception in the way sharks do. We don't come equipped with any natural organs or sensors that let us detect electric fields in our environment. That means we can't feel the heartbeat of another creature through water, and we can't track electrical signals without using machines. However, that doesn't mean we're completely disconnected from electricity. Our bodies run on it. Our brains send signals through nerves using electrical impulses. Every heartbeat is controlled by a tiny electrical system. So even though we can't sense electricity with our skin, we generate it constantly, just like the animals sharks hunt. Some people claim to be sensitive to electromagnetic fields, reporting headaches or tingling near electronics. But science hasn't confirmed this as a real, measurable sense. Unlike sharks, we don't have any physical structures designed for picking up electric fields. To detect electricity, humans need tools like voltmeters, wires, or special sensors. What sharks do naturally, we can only do with technology. Still, learning how animals like sharks, rays, and electric fish sense electricity has helped scientists understand more about how nerves, brains, and signals work, even in humans. It's a reminder that some of nature's best ideas are millions of years old. The shark's ability to sense electricity isn't just fascinating. It's also inspiring innovation in the real world. Scientists and engineers are studying electroreception to develop new technologies that work in water, just like sharks do. For example, underwater drones and submarines can be fitted with sensors that mimic shark electroreception, helping them detect objects or navigate without using sonar or GPS. Medical researchers are also taking notes. Since our own bodies use electrical signals to control muscles and the brain, understanding how animals detect and respond to electricity could lead to better neural implants, prosthetics, and diagnostic tools. Sharks might hold clues for improving the way machines and humans connect, especially in the fields of brain-computer interfaces and robotics. There's also a conservation angle. Learning how sharks experience the world helps us protect them better. For example, by knowing how sensitive they are to electric fields, scientists have designed electric field barriers that guide sharks away from fishing nets or protected beaches without harming them. In the end, this ancient superpower doesn't just belong to sharks. It has the potential to shape the future of technology, medicine, and even how we explore our oceans. Sharks have been roaming the oceans for over 400 million years, using senses we're only just beginning to understand. Their ability to read invisible electrical signals isn't science fiction. It's nature's original blueprint for high-tech survival. And the more we learn from them, the more we realize. The ocean is full of secrets we haven't even begun to decode. If you found this fascinating, just wait until you discover what other wild superpowers animals have evolved to master their world. Check out our video on the 9 animal superpowers you'll want for yourself. You won't believe what's out there. Don't forget to like, share, and subscribe if you want more mind-blowing nature stories like this one. Got a favorite shark fact or animal superpower to share? Drop it in the comments. We love hearing what fascinates you most. Thanks for diving into this with us. Stay curious and we'll see you in the next video.